okay, using the washer technique. That's called washer technique. And I have the picture of industrial washers. I have to do this because a few years ago, one student asked me a question. Why do you call that a washer, this thingy? Because she was thinking washing machine, the one that you do, machine that you do your laundry with. That one. No, no, no. We are not talking about that washer. We are talking about this industrial washer. Okay. Do you guys know where this thing is used, right? When you put the screws on in order to protect the wood, you put this thingy first, then put the screw. Okay. Yeah. Okay. See. God bless America. I have to show you the images of these things. Okay, this is called the washer. And I still don't know why they call this thing washer in this country. Unless, of course, if you're from Texas, you don't call it a washer. Do you know what they call this thing in Texas? They call it washer. They put R in everything. Did you wash this? Like what? What is wash? I remember being confused when I was talking to a Texan. Okay. Before we do that, let's look at the graphics, okay? I have this rectangle, that rectangle, right? I'm going to rotate, revolve, I don't know which is correct, revolve. So AP sometimes call it rotate, sometimes they call it revolve, so I don't know. Revolve this thing about this line, okay? And let's see what that creates, okay? Amazing, this thing never gets old. Huh, how about that, huh? Pineapple slice is what you get out of this. Now, the orientation of the rectangle matters a lot. If it's oriented this way, and then it gives me completely different shape. This is known as a cylindrical shell or cylinder shell. Okay, that's tomorrow's lesson. So it's not this, we're doing this, washer. Get it? Pineapple slice. And then disc is if there's no hole cut out in the middle, that's called the disc. So these two are the same technique, okay? So idea is this. If I have a semicircle, if I revolve this thing around about the x-axis, then can you imagine this thing becoming a sphere? Well, you don't have to imagine because I got this. You know what I'm saying? But how are we going to calculate the volume like that? Well, we don't have to really calculate the volume of that thingy. You remember rectangle approximation, right? Many different rectangles. If it's infinitely many, infinitely thin, that gives me the volume, the area of this semicircle, correct? So all I have to do is revolve one of this rectangle and create this beauty. Right? And then repeat this process. So I create this. And remember, we have seen something like this on your homework question before, right? So if I take infinitely many disks, infinitely thin, that'll be exactly the same as volume of this sphere, is the idea. You get it? You all understand what we are doing now. Then I'm going to go back to this and I'm going to start drawing this thing. So first I'm going to draw a circle. Say we have this circle like so. Black. And then I'm going to draw the axis, say somewhere in the middle like that. Okay. So equation of this, of course, is x squared plus y squared is equal to r squared, isn't it? Good. Now, so dv, I'm going to draw one rectangle now. Say about there. If I have this rectangle right there and rotate this thing around, you have to be very artistic in this business. Oh, by the way, drawing this thingy is mandatory. That's how you show your work. You know what I'm saying, right? Okay, so this thing is a cylinder, sideways cylinder, isn't it? And I'm going to call the volume of that thing dV. Infinitesimal, then volume dV. And what is dV then? Okay, cylinder, hopefully you remember cylinder, volume of a cylinder formula, pi r squared h. Pi r squared is the area of the base, and then h is very thin. You know what I'm saying? But what is y? What is r and h? In this case, this is y, isn't it? Our x, y. And thickness is dx. You know what I'm saying? Because dA used to be y dx, but now this is pi y squared dx. You get it? So pi y squared is the area of this circle. You with me? Okay. Now, what is y squared then? Somebody had that question earlier. We get it from here. If you solve for y, then this thing will become pi r squared minus x squared dx. How about that? Now we are ready to integrate this. So then volume is, so see the most important ingredient, integrand, the meat is ready. So here, instead of from negative r to positive r, why don't we take half of it, because 0 is our favorite number, and double it? Somebody might ask, well, shouldn't that be 4 here? Because there are 1, 2, 3, 4 quadrant. No. See, when you rotate that thingy, it takes care of this entire hemisphere. This quadrant 1 and 4 are both in there. You get it? Then we plug in pi, and then we have r squared minus x squared dx. How about that? Any questions so far in setup? After that, this is a downhill. So we have 2 pi. Is this r squared over 3? No, you don't. R is a constant, so this is just r squared x. And this is 1/3 x cubed. You get it? See, variable. Your only independent variable is x. This thing matters a lot in calculus. You get it? With respect to x. So now we have 2 pi, and this becomes r cubed, and this becomes 1/3 of r cubed. Now, this is 1 minus 1/3, so that's 2/3 of the r cubed times 2 pi. Amazingly, it gives you this. Wow! How about that, eh? Questions? Well, as if that's not amazing enough, then why don't we calculate the volume of a cone? You guys remember cone, volume of a cone formula? Okay, let me put this like this here, like so. And change that to black color. And then I'm going to put a triangle. If I put a triangle like that, and revolve this thing around like this, do you see a sideways cone? Oh yeah, huh? Do you see it? Okay. So, like before, I'm going to draw a rectangle about here. Let's put it like that. Like that, red. And rotate that thingy around, which will give me this shape. All good? Okay, so like before, this rotational radius is y, this is y, and this is dx, isn't it? So our dv, I think I'm going to put it in vertical. dV is equal to pi r squared h, which is dx. Good. Now, only challenge is somebody give me the equation of this linear function. And don't say it is y is equal to mx. My question was, what is the slope of this linear function? What was that?
Is it like you have to do the Pythagorean theorem and find a derivative or something?
No, it's like, okay, let me give you a hint. Yes, Ryan.
Is it r over h?
R over h is correct. Why is it r over h? Remember, volume of a cone is pi r one-third pi r squared h, isn't it? This needs to be h from here to here, the height of the cone, and this needs to be r, the radius of a base of a cone. You get it? So this linear function here is y is equal to r over h x, isn't it? You need a function to integrate. You get it? Dang, huh? Substitute that in. So what we have now is r squared over h squared x squared dx. Good. Now, so my volume here is from 0 to h here to here. You get it? This limits of integration goes between wherever your rectangles and consequently where your disks are located. And then you have pi r squared over h squared x squared dx. Now I'm gonna take all of these constants outside, and then you see where that 1/3 comes from? From this integration. You get it? That looks weird. Substitute. So this thing gives you 1/3 h cubed. Cancel two of those, so r squared h. Huh? Wait, I forgot pi. 1/3 pi r squared h. How about that, eh? Amazing, huh? I know, I amaze myself sometimes. Lastly, do you remember this from yesterday's video? We are going to revolve this about the x-axis. I mean, that's not even imaginable. How do you, we don't have to know, you don't have to imagine this. All you have to do is just imagine revolving one rectangle, okay? So as always, I'm going to draw that one rectangle. Let's throw it about here, like so, and rotate that thing around, so it's going to create, I want that red, rotate that around, so it's going to create something that looks like this. That looks about right. Move this slightly to the right and change it to green color. Okay, and then there will be an inner circle, which will look about like this. Good. You have to be very, very artistic in this business. That didn't work. We have created a washer. Amazing, isn't it? Okay, now I'm gonna have to put down the dimensions very carefully. This is what I call big R. Why don't I don't know why I'm so anal. I'm going to throw it with this. Okay, so this is what I call capital R from here to here, and I'm going to call this lowercase r. Okay, so let's talk about this. The volume dV is equal to, how do you calculate the volume of this thing? Some geometry books have this exact volume problem. It is pi r squared h, which is the volume of this big cylinder without the hole, and you literally cut the small cylinder out. You know what I'm saying? Now, common factor. So r squared minus r squared minus lowercase r squared h. How about that? Good. Now let's remember our function. This function at the bottom was, which we call f of x, right? This was what we call f of x, which was e to the negative x. And this upper function, g of x, is called sine of x, right? So this becomes g of x here, and this becomes f of x here. Good. So we substitute these things in. So what we have is pi g of x quantity square minus f of x quantity square. Okay. Now, at this point, I would like to give you a caution. If you memorize, this happens a lot. Don't even write this down, because it's incorrect. Quantity square is the most common mistake. Instead of difference of square, it comes from geometry. Big cylinder minus small cylinder, so it has to look like this. If I see this, it's automatic 0 and no partial credit. In fact, I've seen some of the answer keys grading scoring guidelines of the AP exam, and they specifically mention 0 point for this, no partial. So don't be doing it, don't memorize it, okay? That's why I want you to prepare the integrand first. After that, V is really easy. Remember A and B? We used to call this point A yesterday, and hopefully your calculator still remembers it. That same A and B. And then we just put this thingy down. Okay, so let's throw this circle. I'm gonna throw it here. Oh, something like, oh, it still worked. How about that, huh? Amazing. Okay, I'm gonna turn that to black, and then I'm gonna throw the coordinate axis right there. Okay. Now we have this thing, and then we have to draw this perpendicular to y-axis. So my rectangles go like this. Okay. So I will have dy here, and this whole thing. Well, that much is x, isn't it? So far, so good. And one of this thingy is what you see here. So I'm going to draw that isosceles triangle. So what we'll have is this thingy. That doesn't look isosceles now, does it? I'm going to draw it 3D. Like that. You know what I'm saying? Yeah, that didn't work. I don't know why I'm so anal. Don't answer that question. So, and this must be 2x here. That makes sense to you? And this is isosceles, right? Triangle, so this must be 2x. Y'all with me? So now my dV here is 2 times 1/2 times this times that, so that must be 2 times x squared dy. This thickness is dy. Y'all with me for the setup? Say yes. Okay, now I need the x squared. X squared, we can get it from here. So x squared is equal to 1 minus y squared. Eh? So substitute that in. So we have 2 times 1 minus y squared dy. Good. Now we can calculate b. B is now from, this is 1, right? Radius 1, so 0 to 1, and we'll double it. And we also have that 2 here, and then 1 minus y squared and dy. Now this is all downhill from here, right? Okay, so that is 2 times, or 4 times, and then we'll have y minus 1/3 y cubed from 0 to 1. Good. So this is 1 minus 1/3 once you substitute 1. So we have 2/3. So with this we have 8/3. Question? Nay? Okay, then we'll go to this 51. This is classic. This is about on every single calculus book there is. Okay? So I'm gonna do this one. So let's start with circle again. So if I have a circle like this, now I'm gonna draw the coordinate axis. That didn't work too well, now did it? Okay. And now this has a radius of r, so equation of this is x squared plus y squared is equal to r squared so far, and this is r, okay? Now we are going to drill the hole here with height of 4 centimeters, okay? We don't know how big the radius is, our only assumption is it's more than 2, okay? So let's throw these things, line, and let's say hole is about that big, right? So we're going to cut this part out. And let's say copy and paste that thing. Did that work? No, not like that. Copy this thing and paste. Okay, that worked. So I'm gonna put them right there. Okay. So all of this is gone. Going to adjust a little bit. Okay. And we are only revolving this region. You know what I'm saying? Round. And we're going to create this bead ring looking thingy. So far with me? Okay, then the question is, which is easier, washer or shell? What do you say? Something tells me, I mean, usually you would think the shell is easier, because it usually is, except look at the function, right? If I draw the rectangle this way, I'm dealing with the square root times some kind of x, right? But if I try to use a washer technique, so whenever you have a circle like this, generally washer, for this reason I'm about to show you, is nicer. If I draw it this way, this is dy. Okay, let's figure out the inner and outer radius. Okay, this is outer radius, which is x, isn't it? That much is x. Now, from here, x is equal to square root. Here, x is equal to, x squared is equal to r squared minus y squared, because we have to square this according to our shell formula. You know what I'm saying? So square root is a very nice function to square. So whenever you have something with a square root, usually go with a washer. So we're going to square it and make this, it makes it very nice to integrate. You got it? Okay, now we have to figure out this inner radius, right? Inner radius is tricky, so I'm gonna draw this triangle right here and figure it out for you. Okay. This thingy, I should not draw it that way. I'm gonna throw it downward because it's gonna get clogged up. So let's go. What? It doesn't want to go the other side. I cannot invert this. Okay, I'm gonna delete it and draw it again. Delete. Erase it. Okay, let's try this one more time. I need this triangle. I'll just fix it later. Okay, I need this side. Now, this whole height is 4. That tells you this side is 2 centimeters, right? And this much is r. So that tells you this inner radius is square root of r squared minus 2 squared. Good, not too much geometry. Okay, now we are ready. So I'm gonna throw this washer. And it looks like that, and outer radius, which will look like this. Okay. So this is the washer I create after rotating this thingy like that. Good, that's my dV. So let's figure out dV here. dV here is pi, and then remember big R squared minus small r squared. Big R in this case is x squared minus small r is that thingy, isn't it? Which is r squared minus 4. And then dy. How about that? Y'all with me? Okay then. And that is, of course, pi of, wait, I messed up. Yeah, I didn't mess up. Now I have to substitute x squared, right, which is r squared minus y squared, and distribute the negative sign, so minus r squared plus 4 dy. So this simplifies to 4 minus y squared dy. How about that? Good? Too much algebra? No? So my volume will be from now, let's use symmetry, from 0 to, how high is this thing? Not to r, but this thing. This thing is 2, isn't it? So 0 to 2, and we double it. Okay, so we have pi, and then 4 minus y squared dy. And that will be 2 pi, and then 4y minus y cubed, therefore 1/3, this is minus, and from 0 to 2. Can somebody, wow, this is a challenging stuff right now, right? Can somebody tell me how to multiply and add? Useless kids. Okay, if I cheat, I mean do it in my head, then it'll be 32 pi over 3. They say unit is centimeters, so cubic centimeters. Now, what is unusual about this part B? Why is this surprising? The reason this is surprising is because this is independent of the radius of the sphere. What? What? I'm gonna get a little more space and give you pretty, well, illustration of what I mean by that. Suppose we have a sphere this big compared to sphere this big, and if we drill the same size hole, you think we'll have exactly same volume? Say this is 4 centimeters. So we are cutting this thing, so this thing creates a bead. There's no way, do you see how big this is, right? There's no way this will be same thing, right? You might think, but let's just, so about the same size, about that much, right? So what we are creating is this ring. We are only rotating that little volume. And all of this thingy is being cut out. So this is farther or longer circumference, but it's a lot thinner, so it ends up giving you exactly the same volume. You know what I'm saying? As long as this height of the hole is the same thing, huh? Question about this one? Before I move on to the next problem, which is 53. Okay, so 53. Okay, first quadrant of this thingy. Oh, x-axis versus y-axis, right? I mean, the reason is also what is A that gives you the same volume? Is that what they're asking? Yep. Okay, so let's do it. So if I have, let's do it in about the y-axis first. So say we have a parabola like that, and do you all see this is A, like that? You know what I'm saying? Okay, at least you should know that much. So I'm going to throw the rectangle. Let's throw it about here. Okay, make that red. And we're going to rotate this thing around. So we're going to create. Sorry about the noise in the background. Okay. My construction is still going. Some of you understood that language, right? Okay, so this is what we have. So this is y from here to here, and this is dx, right? So that seems easy enough. So my dy dv is equal to pi r squared, y squared in this case, and dx, right? You with me? And pi, and my y is this, ax minus x squared, quantity squared, dx. And that is pi, and we have to square it, unfortunately. So a squared x squared minus 2ax cubed plus x to the 4th power. Too much algebra? Ne? So my v is equal to, from 0 to a, and then pi a squared x squared minus 2ax cubed plus x to the 4th power and dx. Good? So far so good? Okay, then that is equal to pi, and then this is a squared x cubed, therefore 1/3 here, good? Minus, and I have ax cubed, to the 4th power. So therefore 1/4 with that, I get 1/2, and plus x to the 5th power, therefore 1/5, and from 0 to a, right? Let's substitute. So this thingy becomes a to the 5th power, this becomes a to the 5th power, this becomes a to the 5th power. So it's a matter of fraction addition, isn't it? Answer is pi a to the 5th power over 30. assuming you can multiply. I mean, this is just addition of fractions. Okay, now we're going to revolve this about the y-axis. Okay, so let's do one more. I think I can copy this much. Can I copy this much? Hopefully. And paste it here. Okay, that much worked. I'm gonna move it slightly over here so I can revolve it about. Those little green thingies. Let's see if I can surgically. I guess it's not as easy. Let's do it over. Okay, great. Why am I so lazy? Okay. So my rectangle will look like this, and thickness the dx. Now, if I revolve it, about the y-axis, then it's going to look like this, eh? And outer radius. Let's start here, and so this is what we get. Good. Okay, now so we create something that looks like this. That's my dv. Okay, so what we have here, dv now is equal to 2 pi r, right? But is my radius here, that's just x, isn't it? And this is y. So we'll have 2 pi r, which is just x, times the height, y, and then dx. Good? Okay, this is why you see the shell is generally easier, x, and then our y happens to be, what was it, ax minus x squared dx, eh? I'm going to just distribute x, so 2 pi, and then ax squared minus x cubed dx. Are we good? Now let's evaluate. So v from 0 to a, and 2 pi ax squared minus x cubed dx. Good? So 2 pi constant, and then I will have ax cubed, therefore 1/3 a, minus, and then x to the 4th power, so therefore 1/4 from 0 to a. Still with me so far? Now, if once I plug in a, this is 1/4, a to the 4th, and this is a to the 4th, so this is 1/3 minus 1/4, right? Times 2. So I will have pi a to the 4th power over 6. So far so good? Now, only thing I have left is I equate this thingy with this thingy, right? So I'm going to do that here. So therefore, what I have to do is pi a to the 5th power over 30 is equal to pi a to the 4th power over 6. And that gives me a is equal to 5. Oops. How about that?